So this is question 1, exercise set 20C.2 from Hayes and Harris, IB Mathematics Higher Level, page 685. Kinematics, just a reminder that V is equal to the derivative of S, where S is displacement, and acceleration is equal to the derivative of velocity. So that means that the integral of acceleration is equal to velocity, and the integral of velocity is equal to displacement. Okay, so we have a function for velocity, write a formula for the displacement S of t. The particle is initially 2 centimeters to the right of O. Okay, so we have velocity and we need displacement, so S of t, this is part A, is going to equal the integral of the velocity function 1 minus 2t dt, which would equal t minus 2 times t squared over 2, so that would just be t minus t squared plus c. Okay. Find the total distance traveled in the first second of motion. So total distance is not displacement because we don't know if this particle changes direction. And when do you change direction? Well, if you're moving along and you're going at a particular speed and you change direction, your velocity has to go to 0. So when velocity equals 0, let's say right here velocity equals 0, you know you change direction. So when does velocity equal 0? When does 1 minus 2t equal 0? Well, that happens when t is equal to 1/2. Okay? So what do we do with that information? Well, so that's after half a second. So what is S of 1/2? S of 1/2 is equal to 1/2 minus 1/2 squared plus c. Well, c, we know. We know that it is initially 2 centimeters to the right of the origin. So at time 0, when t is 0, if I guess I should have done this and solved for c. At time 0, we know the position is equal to 2. So if I had 2 equals 0 minus 0 plus c, then c equals 2. So we can rewrite that, and this becomes 2. So the position, when it changes direction, is going to be 1/2 minus 1/2 squared plus 2, which is equal to 2. No, 2 1/4, sorry. 2 1/4 centimeters. Okay. And let's see, at S of 1, what's S of 1 equal to? Why do we care about S of 1? Because it's the first second of motion. So S of 1 is the position of the particle after it has traveled a total of 1 second. So that would be 1/2 minus 1/2, right? 1 minus 1 squared is, why did I do that? 1/2, I don't know. Sorry about that. 1 minus 1 squared is 1 minus 1 plus 2, so that is equal to 2. Okay? So we have to draw a motion diagram. So we know that the particle started at 2, and we're moving to the right. How do we know it goes to the right? Because the velocity is positive for 2 and greater. Well, no. Well, actually, I guess it would be going to the left because at t equals 2, we get a negative value, but it doesn't matter because if it changes direction, and we're looking for total distance. It really doesn't matter which direction it's going. So we're going to go here, and then at 2 1/4, the velocity is 0, so it changes direction and goes back this way, right back at 2. Okay, so how far did it go? Well, it went 1/4 of a unit this way, and then 1/4 of a unit this way. So it's just 1/4 plus 1/4, and that is equal to 1/2. In part C, find the displacement. Now remember, displacement is the distance traveled between the start and the finish. Okay, and we already know that s of 0 at the start is equal to 2, and up here we found that s of 1 equals 2. So the total distance the particle moved from the start is 0, even though it traveled a half of a unit and ended up right back where it started, so it is 0. All right, that is it for problem 1. I'm out.